at the situation where the region of integration is non-rectangular. So that's another scenario. And so we have non-rectangular region of integration. So in this case, when we have you can have a situation where we'll have this curve, let's say y equal to f of x, and then we'll have another curve which is y equal to g of x. And so where these two curves meet, they form the region of integration. And so when we have the surface area which is given as z equal to f of x and y, therefore you see that the shape, the volume of this, when we find the integration along the z, that is the height, becomes a certain shape, like, but the base is this non-rectangular base. And so we can have the double integral. This is the x-axis, 0, y-axis. And so these two curves will meet at x1, this is x2, and then we'll have y2, and this is y1. In this particular case, my drawing shows that y1 falls at 0, the origin, but it could be any other point, at any other point. And so the double integral about the region R, this is the region R, f of x and y dA, as we said, can also be written in terms of iterated integral f of x and y dx dy. Dx dy, it means that we have to formulate the iterated integral. First, we are working respect to x. And so it means that the inner integral, we are moving the strip along the x-axis. So see that we start this strip from this curve, which is y equal to f of x, and then we move the small strips up to the second curve, which is y equal to, this is y equal to f of x, and then this is y equal to g of x. And so that our lower limit will be on where we started, which is on y equal to f of x, and we'll move along the x-axis, and we come and hit at the curve, start with y equal to g of x, and then we end at y equal to what? F of x. And so our x here, x1, x2, will be the inverse of the various functions. And so our lower limit is y equal to g of x. And the inverse of y equal to g of x will give us x inverse is a function g inverse of y. And so x1 will be a g inverse of y. And then when we move from the lower curve to the upper curve, which is y equal to f of x, the inverse of this curve will be x equal to f inverse of y. That's the inverse function of y. And so we move x2 will be f inverse of y. And now, when we finish the inner integration, then we are going to do the outer integration with respect to y. And so we then move along the y-axis. We move along the y-axis upward. So we start from the curve y equal to f of x, and we end at y equal to g of x. And so the lower limit of the y will be y1 is here, y1, setting y1 is here, that is y1 is here, and then where they will meet, this another y2. This is where the y2 will be. So y1, y2. And so this one moves from y1 to y2, y2. Now, if we also want to work along the x-axis, so our double integral of f of x and y, dy, in this case dy dx, it means that we are going to work the inner integral along first the y-axis. So if you are moving the strip along the y-axis, so that we start from the lower curve. The lower curve is on the graph y equal to f of x. So this y equal to f of x. And then when we move to the lower, we move to the upper curve. The upper curve, the curve which is y equal to g of x. And so the upper limit becomes y equal to g of x. And now, when we finish the vertical demarcation, then we'll take all the strips and we'll move along the x-axis. And so if you are moving along the x-axis, we move along this curve, from this curve up to this curve. So the lower curve will be y equal to g of x, and the upper curve is equal to y equal to f of x. But the x is where they will meet. They will meet here. So the lower one will be x1, and then the upper limit where the two curves will meet will be x2. And so that is how we formulate the iterated integral of any given double integral. Either we move along the x-axis or we move along the y-axis. And so we'll take an example to illustrate how to find the double integral when the region of integration is a non-rectangular one. So quickly, you want to say three? I don't know. So you signal me. So we take an example where the region of integration is non-rectangular, and so we take an example. Say, evaluate the double integral, let's say 2x plus 3y dA, where R is bounded by the curves y equal to x and y equal to x squared. And so to solve this problem, we have to first of all sketch the region of integration. And so we'll sketch the region of integration. So if you have the x-axis, y-axis 0, the line y equal to x is a straight line with a gradient positive, and so it goes through the origin. And so this is a straight line through the origin, y equal to x. And then this curve, y equal to x squared, we all know is a parabola. And so the parabola also passes through the origin. And so it's a curve, it's a parabola which goes like this. And so y equal to x squared. You see that the region of integration is this. So it's this shape which forms the base. And then when we factor in the height, which is the surface area, then we'll get a volume. A volume with this kind of shape. And 3 dimensions will be very nice shape. And so our double integral, the double integral R 2x plus 3y dA, we can formulate it along the x-axis or the y-axis. So let's formulate it along the x-axis first, which will have dx dy, x dy. we realize that these two curves will meet at this point O and let's say point A. And so where these two curves meet, we solve the simultaneous equation. The curve x squared is equal to x. Therefore, x squared minus x equal to 0. Therefore, if we bring x outside the bracket, x minus 1, x into x minus 1 equal to 0. And so, when these two terms become 0, it means that either x equal to 0 or and x minus 1 equal to 0. Therefore, x equal to 1. And so, if x equal to 1, so this is the point, this is x equal to 1. So, and then the y coordinates, if x equal to 1, put here, this is 1, y will give us 1. And so, if you are formulating along the x-axis, you are moving from the lower curve to the upper curve. See that the lower curve will start from the y equal to x. This is the lower curve to the upper curve. So the lower curve is y equal to x, and then the upper curve becomes y equal to x squared. And so we find the reciprocal, the inverse of this. So it means that the lower curve is on y equal to x, and therefore x, if you find the inverse, x equal to y. And then up to this upper curve, y equal to x squared. And so if we take the inverse y equal to x squared, we're going to have x is equal to root of y. We are taking the positive value of root of y because we are working in the first quadrant. See, if you are working in the third quadrant or the second quadrant, then the value of x becomes negative. But from this sketch, we see that we are working in the first quadrant. So there's no need to put the negative sign there, which means that the inverse of y equal to x squared becomes x equal to square root of y. We take square roots from both sides. And because we are working the first quadrant, we don't take the negative square roots. And so the upper, we finish with the x. Now when we finish the integration, the inner part, then we'll do the integration along the y. And the y starts from the point 0 to 1. 0 to 1. 0 to 1. And so let's quickly take this one off. Right? Quickly this one off. And then we will integrate. So we have integral from 0 to 1. Now we are integrating with respect to x. So we keep y as constant. Let's take note of that. So if you integrate 2x respect to x, you're going to get 2x squared over 2 plus, if you integrate 3y respect to x, you get 3xy, and the limit is from x equal to y to x equal to root of y, all times dy. So let's put in the limit. So the first one, the upper limit is x equal to root of y, and so we'll get 2 and 2 will cancel, right? So we're going to get x squared. X squared means root of y squared. So root of y all squared, right? Plus here 3 times x equal to root of y. So 3 root of y times y. And then all of them, we'll put the lower limit to the lower limit. The lower limit is x equal to y. So when we see x, we put y. So we get y squared, that is y squared minus 3x. X is y, 3yy. So which is 3y squared minus 3y squared all times dy. So let's tidy up. When we tidy up, we're going to have integral from 0 to 1. And then root of y squared will give us y. Right? Plus root y is the same as indices y raised to the power half, and y is to the power 1. So if you add half to 1, you get 3 over 2. So we're going to have 3 y raised to the power half plus 1, which is 3 over 2. And then minus y squared minus y squared minus 3y squared. That will give us minus 4y squared. And then you take the y. Now we are going to integrate with respect to y. So if you integrate y with respect to y, we get y squared over 2. Plus, if you integrate 3y raised to the power 3 over 2, you get 3y 3 over 2 plus 1, all divided by 3 over 2 plus 1. Then minus, if you integrate 4y squared, we get 4y cubed all over 3. And the limit is from 0 to 1. And so let's tidy up first before we put the limit. If we tidy up first, we're going to have y squared over 2. Now, 3 over 2 plus 1 will give us 5 over 2. That will give us 5 over 2. 5 is divided, and so 2 will go up. So we're going to have 3 times 2 divided by 5, and then we have y raised to the power 5 over 2, and then minus 4y cubed over 3, and the limit is 0 to 1. And so if you put the upper limit, which is 0, which is 1, 1 squared is 1, so we're going to have half plus 3 times 2 is 6, 6 over 5, minus 1 cube is 1, minus 4 over 3. And so we're going to find the LCM of this term, and it's 2, 5, and 3. The best LCM, I believe, is 30. So we're going to have 30 as the denominator. 2 will go to 30, 15. Then we have plus 5 will go to 36. 6 times 30. 6 times 6 is 36. Then minus 3 will go into 30, 10. Minus 40. 15 plus 36 will give us 51 minus 40, all divided by 30. And so 51 minus 40 will give us 11 over 30. And so that gives us the value of the integral along the x-axis.
2, 1.
So we are going to take the same example. This time we are going to work along the y-axis. So we are going to work along the y-axis. And so this one becomes the double integral of 2x plus 3y dy dx. So it means that the formulation of the iterated integral will be that you are moving along the y. So if you are moving along the y, we move from the lower curve. This curve, the strip will go up. So move along, start from y equal to x squared, and then we end at the upper one, which is y equal to x. So here the lower limit will be y equal to x squared, and then the upper limit will move from y equal to x squared to this curve, which is y equal to x. That will conclude the integration using the inner values. And then when we finish with these strips, we'll see that we move along the x-axis. And we move along the x-axis, that is, we move from x equal to 1, x equal to 0, to x equal to 1. So x equal to 0 and x equal to 1. And so now we can do the inner bracket. But let's remember, we are integrating with respect to y, and so we'll keep x as constant, treat it as constant. And so this one becomes integral from 0 to 1. If you integrate this one, get 2xy plus, if you integrate 3y respect to y, we get 3y squared over 2. The limit is from x squared, y, that is y equal to x squared, to y equal to x. When we finish, we'll do the respect to x. And so let's put in the limit, 0 to 1. Upper limit, where you see y, you put x. Put y equal to x. So we're going to have 2x times x plus 3. When you see y, we put x. So 3y squared, which is 3x squared over 2, minus lower limit. Minus lower limit is x squared. So when you see y, we put x squared. So we're going to have minus 2x times x squared minus 3 over 2, y squared becomes x squared all squared, which is x squared all squared, x squared all squared, dx. And then, so next is to tidy up. Let's tidy up quickly and see what we have. So 2xx will give us 2x squared, then plus 3 over 2x squared, then minus 2x cubed, minus 2x times s squared, 2x cubed, minus 3 over 2 x raised to the power 4, x raised to the power 4, all dx. Let's see if we can still tidy up. We're going to have 0 to 1. 2x squared plus 3 over 2x squared. That will give us 7 over 2, 0 over 2x squared, 0 over 2x squared. And then minus 2x cubed minus 3 over 2x4, all dx. So now we are going to integrate with respect to x. And so we're going to have, this one will give us, if you integrate x squared, you get x cubed over 3. So we're going to have 7 over, we're going to have x cubed over 3. 3 times 2 will give us 6. So x cubed here. Now minus, if you integrate 2x cubed, we're going to have 2x4 over 4. So 2 and 4 will reduce. So we're going to get x4, 2 going to 2, 1, 2 going to 4, 2. So x raised to the power 4 over 2. And then the last one will be 3 x raised to the power 5, x to the power 5 over 5. But there's a 2 here. So 5 times 2, that will give us 10. And so the limit is 0 to 1. If you put the upper limit, see that everything becomes 1. So we have 7 over 6 minus 1 over 2 minus 3 over 10. 3 over 10. And so this one, the LCM, was 6 to 10. I think the LCM should be 30, right? 30. And so 6 will go into 30 and 5, 7, 35 minus 2 will go to 10, 15. 15 times 1 is 15 minus 10 will go into 33. 3 times 3 is 9. And so if you tidy up, we're going to have 20. We're going to have this one will give us 0, 20 minus 9 over 3. That will give us 11 over 30. 11 over 30. And so that concludes the integration along the y-axis. So we'll see you in the next video where we'll look at other forms of double integration. Thank you very much and enjoy the rest of the day.